The SCHMID Vanadium Redox Flow Battery consists of two tanks storing vanadium analyte and catholyte. Pumps are used to flow these electrolytes through adjacent half cells separated by an ion exchange membrane. Within the half cells, the electrolytes are chemically oxidized and reduced to reversibly convert electrical to chemical energy. An external electrical power source like PV installation supplies the energy to charge the vanadium redox flow battery. The two vanadium electrolytes are flown through the cell stack in which the electrical energy is converted to chemical energy. The electrolytes charged within the cell are flown back to the tanks, increasing the battery's state of charge. Looking into the cell at the molecular level, vanadium-3 and vanadium-4 enter the electrochemical cell. At the catholyte half cell, the vanadium-4 is oxidized to vanadium-5. This chemical reaction yields an electron which is drawn off by the conductive electrode material and a hydronium ion which diffuses across the membrane to the opposite half cell. At the anode half cell, the electron which has traversed the external circuit reduces vanadium-3 to vanadium-2. The hydronium ion which has passed the membrane balances the overall charge of the half cell. The two electrolytes leave the half cells in a charged state as vanadium-2 and vanadium-5. Once the grid cannot provide energy to the battery system, the vanadium redox flow battery swaps to discharge. Vanadium-5 and vanadium-2 ions carry the chemical energy into the cell stack. The chemical energy stored within the two electrolytes is converted to electrical energy, feeding the external load. At the molecular level, the reverse of the charging reaction occurs. Vanadium-2 is oxidized to form vanadium-3, releasing an electron which carries the electrical energy. For charge balancing, a hydronium ion crosses the ion conductive membrane. Vanadium-5 is reduced by an electron under consumption of a hydronium ion. The electrolytes leave the cell in their discharge states in the form of vanadium-3 and 4. The vanadium redox flow battery delivers electrical power until the electrolytes within the two tanks are completely discharged. The SCHMID Vanadium Redox Flow Battery can be independently scaled for appropriate power and energy. Power can be adjusted through cell size and number. Energy is defined by the tank volume to perfectly meet the customer's needs. As the electrochemical reaction takes place in the electrolyte solution, no loss in power or capacity takes place due to side reactions as observed in conventional batteries. This fact ensures lifetimes superior to any other electrochemical storage. Even deep discharge does not influence battery health. Unlike other flow battery types, the all-vanadium redox flow battery incorporates vanadium in both electrolytes, eliminating battery deterioration through cross-contamination. The composition of the electrolytes, vanadium salts solved in dilute sulfuric acid, guarantees low hazard potential and best possible ecologic properties. With all these benefits in cooperation with low production costs, the SCHMID VRFB is the appropriate means for renewable energy storage.